In this problem, 5 is subtracted from 8. 8 is called the minuend in the problem, 5 is called the subtrahend, and 3 is called the difference. So the minuend can be thought of as the amount that we have. The subtrahend is the amount we're subtracting, and the difference, 3, is the answer in our problem. Now, the number line can be used to illustrate subtraction actually in a couple of different ways. The minuend 8 can be identified, you see, as, well, let's see, it's from here to right here. So I might think about, okay, it's that distance, you see. And then the subtrahend is a different distance, it's 5. And the difference between them would be this distance, you see. How long is that? Well, let's see, how many units is it? 1, 2, 3. You see it's 3 units. So that's one way we could think about the situation. Then we could think of it another way like this. We could think, well, if adding means that we accumulate distance and therefore go in this direction, then subtraction might mean that we take away distance and so we move back in the other direction. So we could proceed like this or think through it like this. We think, well, let's take the minuend. That's this distance up to 8. That's all of this. And then let's come back in this direction. You see, let's go back this way, a distance corresponding with the subtrahend. So we'll march back this way 5 units. So from here, we'll go back 1, 2, 3, 4, 5. You see, we come back 5 units. And where do we end up? We end up at 3. You see, just 2 ways to use the number line. But once again, it's not going to always be the case that we can use the number line because it just won't be convenient. The numbers will be a little too big. The nice thing about subtraction is that we can check our work. And we might notice here that in this process, if 8 minus 5 is 3, then it's certainly the case that 5 plus 3 is 8. That is, the check involves using all of the ingredients here and just putting them together into an addition problem to make sure that this is correct. Now, it's subtrahend plus difference is equal to minuend if this is correct. So we would come back, we would come over to the side maybe and say, let's check this. Let's take the subtrahend and add the difference, you see, from over here. And do we get the minuend that we had over there? Well, let's see, 5 and 3, oh, that's 8. And 8 is indeed the minuend over there, so we must have done the problem correctly. These words and word phrases lead to subtraction. The word minus implies subtraction. 8 minus 3 is 8 minus 3 like this, pretty obviously. 7 less 4 is 7 minus 4, you see, or 7 subtract 4. Now, here's one that's related to these two, and this one is not obvious. 5 less than 9. It's often thought that in performing operations that the operation symbol will simply fall in the spot where we have our word or word phrases. And that certainly can be the case with addition because the order in which we add numbers can be swapped. We have the commutative property of addition. But we certainly don't have a commutative property for subtraction. It makes a big difference, the order in which we write the numbers to be subtracted. All right, so it's important that we see this in the correct way. 5 less than 9. 5 less than an amount which we apparently already have. You see, it's implied that we have this, and we want to take 5 from that. 5 less than, 5 smaller than 9. It's really 9 minus 5. And notice that the order in which these numbers appear in this phrase is different from the order in which the numbers appear over here when we actually perform the subtraction. 8 decreased by 2. That means 8 minus 2. We're decreasing this number by that amount, so we're subtracting this amount from 8. The difference between a couple of numbers. Now, difference is the answer in a subtraction problem, so it's no surprise that difference between would lead to subtraction. The real trick is to write the numbers being subtracted, the minuend and subtrahend, correctly in the problem. And it turns out that when difference between is used in a word phrase, that the first item after difference between, the very first item is the minuend, and the second item is the subtrahend, you see. And notice that and is used here, but and certainly doesn't imply addition here. The and is just illustrating the numbers that are involved in this subtraction situation. So difference between 7 and 4 means 7 minus 4. All right, that's the idea. Here we're taking 13 from 48, and once again, when we go through the process arithmetically, it's important to align the digits which have the same value. That is, we want to align the ones digits, the tens digits, and so on. When we set this up for subtraction, we write the 48, and then we want to subtract 13, so we write it like this, with the ones digits, the tens digits. And now we just subtract digits of corresponding value. So 3 from 8, take 3 from 8, we get 5. Take 1 from 4, we get 3. Our answer is 35. If we want to check it, and we certainly do. Remember, that process is one where we just take the subtrahend and add the difference. So it would be 13 plus 35, and we're trying to verify that we get the minuend in this process. So 13 and 35, let's see, 3 and 5, 8, 1 and 3, 4, 48. Is that the minuend from above? Yes, it is. So this is a correct answer. Here we have 726 minus 254, and this one is going to involve some borrowing. We have 726, and we're subtracting 254. Now, once again, we're just aligning digits of the same value, ones, tens, hundreds. Now, we're taking 4 ones from 6 ones, and that leaves 2 ones, so 2 here. Then 2 minus 5. We're trying to take 5 tens away from 2 tens. Can't do that. We don't have enough tens here to take 5 from, you see. So we need to go to the neighbor of higher value and borrow. So we're going to borrow some value from the 7. Now, in that process, we strike out the 7, and the 7 becomes a 6. And the one that we borrow, the 100 that we're really borrowing, is 10 tens. You see, so we're really adding 10 tens to the 2 tens that we already have to give 12 tens. Now, we can put a 12 up here, but normally we would just put a 1 right here to indicate that we have 12 tens here. We're going to take that 12 tens, subtract 5 tens, and we get 7 tens. And then 6 hundreds minus 2, 6 minus 2, 4. So 472 for our answer. Once again, we could check this. And before we even started the process, by the way, we could have estimated what we might expect the answer to be. And by the way, let's go through that real quick. If we were estimating an answer here, then to the nearest 100, well, let's see, this would be about 700, and this would be, let's see, to the nearest 100, that would be 300. 700 minus 300, oh, that would be about 400, and we're in the neighborhood of 400 here. You see, if this turned out to be 67,000 or something like that, we would know that we have an incorrect result, and we would have to be a little more careful with the calculation. Here's another problem. Let's run through the process of subtraction in this problem. We might begin by estimating a reasonable answer, and we'll do that by rounding the numbers that are involved here. And notice we're subtracting 678, so we might round both numbers to the nearest 100. 4,392 to the nearest 100 would be 4,400. 678 to the nearest 100 would be 700. Now we wish to subtract. Now, thinking from the right digits, the zeros are trivial, so we'll just bring down zeros into the answer. Now, as we look at 4 minus 7, and we're looking in this column, now we can't take 7 from 4, so we're going to have to go through the borrowing process. We're going to have more to say about this in just a little bit, but very quickly, here's what happens. We go over to the neighbor, and we borrow 1 from the 4. The 4 becomes a 3. The 1 that we borrow makes this 14. And now we can subtract. 14 minus 7 is 7. And then in the next column, bring down the 3. So 3,700 is our estimate. And let's see if the problem doesn't come out to be very close to that. We begin our thinking by looking at the very first column at the right. We're thinking about taking 8 from 2. Well, we can't take 8 from 2. 8 is larger than 2. So we're going to have to borrow. We look over at the 9 and we think of the 9 like this. Now here's a thought process that gives a reasonable idea for why the borrowing notion works. We think of 9 as 8 plus 1. The 1 part of the 8 plus 1 is really 10 of the items. It's really 1/10, but it's 10 of its neighbor's value. You see, and that would apply true for any of the digits that are involved here. It is 10 of the things that are in the next column. So it's 1/10 or simply 10. So we take that 10 that we borrowed and add the 2 that's already there, and we have a total of 12. And now we have 12 in this position, and now we can subtract the 8. Of course, that's not the way that we will go through it. When we actually perform subtraction, we think about it and write like this. We think, okay, we can't take 8 from 2, we're going to need to borrow from the 9. So we strike out the 9 and replace it with an 8. And the 1 that we borrow causes this to be 12. And we can write a little 1 like this next to the 2 to make it 12. Or it's customary to do this. Just strike out the 2 that's already there, add the 2 to the 10 that we borrowed, and we get 12. And now we can take 8 from 12, and that gives us 4. All right, in the next column, we're looking at 8 minus 7, which is 1. In the next column, we're trying to take 6 from 3. Well, we can't take 6 from 3. 6 is larger than 3. So again, we're going to have to borrow. We borrow from the neighbor. The neighbor is 4. So we'll strike out the 4, and the 4 becomes 3. The one that we borrow is added, you see it's like 10 added to 3, so it's really 13 in this column. And now 13 minus 6 is 7. And in the next column, 3 minus vacancy would be 3. So 3,714. Very close to our estimate of 3,700. So this is a reasonable answer. Consider this problem. It contains a number of zeros in the top number, and that means we're going to have to borrow quite a bit. So we're looking first in this column. We're thinking, gee, we can't take 7 from 5, you see. So we're going to have to borrow to add value to that 5. And we can't borrow from those zeros, so we have to go all the way over here to the 6 and borrow from the 6. And that borrowing transfers only to its neighbor. So we borrow from the 6, it becomes a 5. The one that we borrow is really 10 of this neighbor, and 10 and 0 is 10. And now we have a value of 10 for this sort of digit. And we borrow from that 10, and that 10 becomes a 9. The one that's borrowed is 10 added to this digit, so it's 10. You see, 10 added to 0 is 10. So now we have 10 as the value in this column, and we borrow from the 10. The 10 becomes a 9. The one that we borrow is really 10 of the items in the next column, so we add 10 with 5 to get 15. And now we're ready to subtract all the way across. 15 minus 7 gives us 8. And then our thinking goes to the next column. 9 minus 6 is 3. And in the next column, 9 minus 1 is 8. In the next column, 5 minus 2 is 3. And in the next column, 4 minus 3 is 1. So our answer is 13,838. Here's a word problem which is solved using subtraction. It says, the tennis coach at a high school purchased a video camera that cost $1,079 and made a down payment of $180. Find the amount that remains to be paid. Now, notice that there's no word or word phrase that would lead us just automatically to realize that we need to subtract. It just says find the amount that remains to be paid. We have to understand what's going on in the problem in order to determine that subtraction is what we need to do. You see, the tennis coach is purchasing a camera. The camera cost $1,079. The down payment is made. The coach is paying a certain part of this you see, as this down payment. So $180 is being paid. What is left to be paid, what remains to be paid, you see, is what we're finding out. And to find it out, we need to find the difference between these two. That is, we need to take the 1,079 and subtract 180. So we come out to the side and we do that. And if we were using the calculator for a problem like this, I would want to make an estimate and then perform the calculation on the calculator. But here we're doing it by hand, so I'm not going to estimate it. I'm pretty confident that we can do this correctly. Let's see, we have 1,079. We have the subtraction of 180. Notice that, again, we're aligning the digits of the same value vertically. 9 minus 0 is 9. And then 7 minus 8, oh, we can't take 8 from 7. We don't have enough value here. We go to the neighbor to borrow, and the neighbor is empty. You see, no value here either. So we have to go all the way over to this digit, and we're borrowing from the 1, and the 1, once we borrow from that 1, it becomes 0. There's nothing left. Now, the 1 that we borrow makes this 10, and now we're borrowing from the 10. The 10 becomes a 9, and the 1 that we borrow makes that 17. So we have 17 minus 8. Well, 17 minus 8 is 9. And now we slide over. 9 minus 1 would be 8. So $899, and it's $899 that remains to be paid for this camera.